Welcome to another session with me, Varun, on TechTablet. And in this session, let us understand what is logistic regression and everything that you need to know about it. In the previous sessions, guys, we've already covered what is linear regression, how do we work on linear regression, two parts of linear regression. But in this video, instead of making two videos of the same topic, I've tried to combine all of them into one and present it to you. So let us understand without wasting time what is linear or what is the logistic regression, how is it related to linear regression, the different types of logistic regression, advantages and disadvantages associated with the same, some assumptions and use cases related to logistic regression. And as you all know, I am Varun and I work on R, Python and TensorFlow. And I started my career or I started work with SAP ABAP, moved on into SAP UI5, then started being a YouTuber, and this is the channel that I started, TechTablet, in order to help at least a few. Then I came on to making rap videos with the name of Hi Chora, that is Hyderabadi Chora, and currently I'm working as a data science trainer, a YouTuber, and a data science developer as well. All right, and for all those of you who have queries or who would want to follow me back, you could do that on Instagram on my account, that is Hyderabadi_Chora. This is the same account on which I also make rap videos. So yes, all those of you who are a bit into art and who would like to listen to music, please check them out. Now going forward, talking about logistic regression, as we all know, guys, it is the most important machine learning algorithm, or it is rather the first preferred, or it is the first classification algorithm, is what I would say, after invention or after we have linear regression has come into picture. Now, logistic regression is also a machine learning supervised algorithm, and it is used to predict the probability of a categorical dependent variable. These three terms are very important: categorical, dependent, variable. Now, in logistic regression, generally the values are 0 and 1. Now, here I would say that this is 0, which is no, and this is 1, which is yes. All right, so I have two classes, as you're able to see, and it splits them into two. Now, instead of fitting a straight line or a hyperplane, now straight line is where we use linear regression. Hyperplane, we use that in SVM. But anyways, instead of using a straight line or a hyperplane, we use a logistic function, because of which we would be having a sigmoid curve. Now, this curve or this area which you're seeing here, this green line that you are able to see, is called a sigmoid curve. Now, this sigmoid curve, we use a logistic function to squeeze the output of linear equation between 0 and 1. Now, that is the reason why the usage of sigmoid curve comes into picture. Now, going forward, when we are talking about the different types of logistic regression, there are predominantly three types. The first one is binary, which has responses of only two possible outcomes. This is the one which we use the most. The second one, as you are able to see, is ordinal, and ordinal is for three or more categories. All right. And here, when you talk about ordinal, there is no ordering. You will not be able to order them. But when you talk about multinomial, they are also for three or more, but you would be able to order them. For example, rating. I would be able to rate my movie, somewhere from 1 to 5, and that is something that can happen. I can rate them and I can order them, like ones come first, twos come later, threes come fourth. But when you talk about a vegetarian, non-vegetarian, and a vegan, how would you judge who is first or who is second or who is third? So it would be very difficult, or I would say we would not be able to order something in ordinal. That's how you could probably remember them as well. Now, going forward into the next part, after now that we've completed the types, let's understand some advantages and disadvantages related to logistic. Well, the disadvantage is very simple. That is, it cannot solve non-linear data. Guys, if your data is linear, you're good to go. That's as simple and as straight as that. Because when you talk about the decision surface or the decision making surface, it is built on the linear principle. So anything which is non-linear data is not suitable for logistic regression. But then There are a lot of advantages that you would definitely be interested to listen. The first one is it's pretty efficient. It does not require many computational resources, and it is very highly interpretable. Yes, you already seen a figure and you understood that. And also it does not require input features to be scaled. This is something you can avoid because logistic regression is equipped to handle that. It does not require any tuning. It's easy to regularize, and also it outputs well calibrated predicted probabilities. So the predicted probabilities which you have, I would definitely say that they are dependable. Or that it's not that the output values cannot be dependent on, for example, naive Bayes. That is one model which we all probably know about. Okay, now if you don't know what naive Bayes is, please go back to my videos and check what naive Bayes is. I've already made a video on what is naive Bayes, and I think you should be able to understand something about what it is. Now, what are the different assumptions that we would want to follow when you're working on logistic regression in specific? Right? So here, as you can see, the first one is multicollinearity. Now, when you're working on logistic regression, guys, there should be minimal or no multicollinearity among independent variables. This is the same rule for linear regression as well, if you people remember. Now, the second one is sample size. When you talk about logistic regression, they require a large sample size. Okay, okay, now I don't think I should have cut it out. Okay, now they require a large sample size. Now, talking about independent observations, it assumes that the observations are independent of each other. So the first three rules are it should be there should be no multicollinearity. The second one is the sample size of the training set should be heavy. The third one is the independent observations are or should be independent of each other in order for your logistic regression to work well. Now, the other two assumptions which we have are the logistic regression, which has two classes, assumes that the dependent is binary and the independent is not. All right. So here you can see the dependent variable is binary, and ordered logistic regression requires the dependent variable to be ordered. For example, too little about right too much, your system wouldn't be able to understand this. You will have to tell your system that it is 0, 1, and 2. You have to assign values that this is 0, this is 1, and this is 2, or something like that. Right? Now, the logistic regression assumes that independent variables are linearly related to the log of odds. You all must know what log of odds is, guys. If you do not know what log of odds is, I'll be making another video very shortly talking about the mathematics behind what log of odds is and how it becomes very important. And it's because of this log of odds that you have this kind of a curve that is squeezed in, between the values of 0 and 1. Now, going forward, there are some great use cases that you have for logistic regression. The first one is for spam detection. As you can see, we can use this to detect spam, wherein if it is 0, the mail is a spam, and if it is 1, it is not a spam. Tumor prediction: if it is 0, it is malignant, and if it is 0, it is benign, and if it is 1, it is malignant. Then you have credit card fraud, wherein you can see if it is fraudulent, it is not fraudulent, it is 0, and if it is fraudulent, it is 1. Marketing. So guys, again, here also in marketing, you can see if it is success, it is 0, and if it is failure, it is 1. Now, now let's consider a small example here. We'll consider probably one of these case studies. I would be taking credit card fraud. Now, I would be checking his CIBIL. I would be checking his 5 years history. I would be checking his bank balance. Okay, I would be checking his account value, or I don't know, I would be checking X, Y, and Z. And based on all of these parameters, if the value is 0, he's fraudulent customer, and if it is 1, he's a good customer. That is how at least I would try to classify my output matrix to be, or that's how I would want to classify my fraudulent data set to be. So guys, these are some use cases that we have with regards to logistic regression. So I really hope you have understood what is logistic regression, where we use this, how we use this, and why is logistic regression really required. Now guys, please do me a favor. If in case you like the video, please hit the like button out there. And if in case you have any queries, please use the comment section below. And also do hit the subscribe button, because when you do this, it would motivate me to make a lot of videos. And also when you hit the bell icon, you would be notified whenever I make a new video on any of these. And also very shortly, we would be working on the coding part or the technical side of all these theory videos. So guys, do not go away anywhere. Stay tuned, stay subscribed, as there's a lot that is yet to be exchanged between us and a lot to be seen. Thanks a lot. Have a great day. This is me, Varun, signing off.